Yeah. And as of today, we continue with our revisions, preparation for the final examination. And so we have question number 4 of the year 2021, microeconomics. That was section B. So we had question 4 from section B, 2021 of the paper microeconomics. And so we need to go through this question. I have strategically selected this question, question number 4, because using this question, at least I can easily communicate, send the information properly that I want to send. Okay. So let me just confirm one more time you are able to see the screen and yeah, are able to hear me. Hello? Yes, sir. Okay. All right. Let me just see. Let's just start going through. Okay. So question number 4 is saying, suppose you have the demand function, that you're given, and you also do have a supply function. Then you are to answer the following questions, riding on the same demand and supply function that you actually have. So you have the supply function, you also have the demand function, and so you are expected of answering some questions, and that is what you are expected of doing. Okay. So what questions are we supposed to answer riding on the same demand function and the supply function? Okay, just a minute. Okay. Sorry, I had been logged out. I think we can just continue from where we ended. Those that are able, let's continue. Yeah. So I was saying that we are looking at question number 4 one more time. Suppose the demand and supply function, of the gym membership is given, and you have the gym membership quantity demand given as a function 600 minus 10p, and this function is defining the demand for gym membership. And then you have another function that defines the supply of the same membership, that is gym membership. So it is supplied by this. So the required is to determine the equilibrium price and equilibrium quantity. Okay, so now the first thing that we need to bear in mind before we continue solving the question is that, you know, at equilibrium, we learned that at equilibrium, this is a point where demand equals supply, right? In other words, at equilibrium, demand, you know, is always equal to supply, right? So quantity demanded equals to quantity supplied. And so for that matter, we are going to just equate these equations, right? We're going to equate these two equations, equate them to each other, because quantity demanded and quantity supplied is equal at equilibrium. That's the message that we are actually sending. So you say 600 less 10p, you know, to equal 10p less 300. And then from there, we can collect like terms together so that we can have 600 plus 300. Get this 300, cross the equal sign to the other side. You shall have 10p plus 10p again, because this negative 10p is going to cross an equal sign coming to the other side of the equation. Is there any question? Are we all following? Are we still connected? Okay. Then from there, you can easily say 10p plus 10p. What do we find when you say 10p plus 10p? You know, adding 10p plus 10p, what do we find? I know that 600 plus 300 is 900, equal to 10p plus 10p gives us 20p. And so we can divide through by 20 to find the equilibrium price throughout, so that the value of p can be equal to how many times does 20 get into 900? It should be, you can still cancel 1 0 and you cancel the other 0, so that you can say 2 into 90 goes 45 times. So the equilibrium price is what? Is 45. So this is how you deal with this function. Of course, if the function is not inverted like that, it's just a straight function or a forward function like that. But we have just found the price. We have not yet found the quantity. We also need to find the equilibrium quantity. Now listen carefully. If you want to find the equilibrium quantity, it is very important that at that point you equate, right? Equate or set equal to each other. We begin by setting equal to each other quantity demanded and quantity supply function. Then we find the price, right? So when we want quantity, you can pick any of the functions. You know, you can pick the quantity demanded function or the quantity supplied function. They give you the same answer. So what you do is you choose one of them. Choose one. You can either choose the quantity demanded function or the quantity supplied. And wherever there is P, you replace by putting what? By putting the price, which is 45 in our case. And so what function are you choosing? Anyone to just choose any function of their choice? Am I audible enough and can you see the screen? Is there anyone who is able to just confirm you can hear me and I'm not just talking to self? At least people are following. Or maybe I'm not clear. The line is cutting or something. Okay. Anyways, we can go ahead and choose, for example, quantity demanded function, and that's the one that I'm going to choose. So we can write the function minus 10p. Where there is p, we just, you know, replace by putting 45, so that you can have 600 less 450. And that should actually give you 150. So the quantity demanded should be 150, right? 150 is a equilibrium quantity, right? This is the quantity that brings the market into clearance. And when you say that the market has been brought into clearance, you are simply saying that at that point, demand is now made equal to supply. Okay? That's the message that we are sending. Please, every time you are given such functions, work with them in that order. But there is a very important point that I need to score. And the point is, for example, the equilibrium price, you can still substitute the same equilibrium price into any of the function, including the supply function. You still get the same. You will still get the same answer. You will still get the same answer, right? For example, you can get the supply one now, which is 10p. 10p, 10 times p is 45 minus 300. So 10 times 45 is 450 minus 300, and that gives you 150, which means that you can either substitute in any of the functions and you still be able to get the same answer. Now listen, this function or the functions that were given in this question, they are normal functions. They are not inverted. However, sometimes you may find the functions that are inverted, and this point you should take it home. The take-home message is that sometimes the functions that you may have are inverted functions, or they may be inverted, right? Which means at that point, these functions shall have P or price made the subject of the formula. I repeat, the functions will have P made the subject of the formula. For example, let's invert. Let me just show you the inversion of the demand function. So we have the quantity. Let's just put it quantity now equal to 600 less 10p, right? This is the normal function. Inverting this simply means making p the subject of the formula. And so you shall have 10p, it has crossed the equal sign, equal to 600 minus what? Minus q. You're following, right? This q has also crossed the equal sign to the other side. We're just trying to, play with math and make P the subject of the formula in this function. And at this point, you can go ahead and divide through by what? By 10 and by 10 everywhere, so that you can make P the subject of the formula. And so when you do that, you're going to have P the subject of the formula. P is made the subject of the formula as 10 into 600 is 60 minus 1 divided by 10 should be 0. There is 1 here. We know that there is 1 here. So 1 divided by 10 is basically 0. Then when you add 0, it will be 0.1, right? That will be 0.1 here. Okay. So this is the inverse of what? Of the demand function that we have. In other words, it's the same function. So sometimes an examiner may give you the function that is inverted like this one. And then the other side, maybe the supply function. The supply function is not even inverted. Okay. At that point, listen very carefully. At that point, if one function is inverted, then the other is not inverted. It is very important that you make the functions take the same form, right? If you are inverting, you're working with inverted functions, then you go ahead and invert all the functions. Okay, invert the other one which is not inverted so that you work with inverted functions throughout. It does not work if you just have you have different forms of the function. The other one is a normal function, the other one is inverted. That is not how it works. Make sure if they are normal function, all of them are normalized, they are normal functions. If you have the other one that is inverted, you can either normalize it or invert it as well, or invert the other one too. The message we are sending is that before you can go ahead and say quantity demanded is equal to quantity supplied, ensure that the quantity, the functions you have, the supply function and the demand function, take the same form. All right? That has been made clear. So now, let me go ahead and also invert this one. We see if we find the same answer. Let's invert the supply one as well. We are making P the subject of the formula. So you have Q equal to 10P minus 300, right? So we can easily make Q the subject of the formula. So you say Q plus 300 is equal to 10 what? 10P. Divide through by 10, everywhere by 10, so that you can make P the subject of the formula. That's what we are doing. Make P the subject of the formula. And so at that point, then P, this is P for the supply, shall be equal to 0.1 Q plus 300 divided by 10 is 30, equal. That is what that is going to be equal to. Or if you may like, this same one, you know, this same function can still be written as 30 plus 0.1 Q. This is still one and the same thing, basically. Nothing much. There's no difference. So now, if your functions take this form, then you can go ahead now and, work with the condition that you have. So to find the equilibrium price, okay, I want you to pick this message clearly. You know, this is a very important conversation. To find, if you are dealing with inverted functions now, we already showed you how to work with the normal functions. Now we're showing you how to deal with the inverted functions. To find the equilibrium price or equilibrium quantity, you go ahead and equate the two functions equal to each other, riding on the knowledge that quantity demanded, you know, at equilibrium, price is equal. The price that brings the two markets, that is the supply and demand, to be in equilibrium is just one. So they are equal. The price for supply and price for demand, they are just equal. So at that point, we can just equate these equations equal to each other, right? 0.1, you know, Q equal to 30 plus 0.1 Q. You're following, right? And then from here, you can easily collect like terms together so that we can have 60 minus 30 equal to 0.1 Q, you know, plus 0.1 Q. You get this 0.1, cross the equal sign to the other side. And when we get here, you can go ahead and say 60 minus 30. I think that should give you 30, right? Equal to 0.1 plus 0.1 is supposed to be 0.2 Q. And you divide through by 0.2 and by 0.2. What do you find as quantity? We want to make quantity the subject of the formula. We're making quantity the subject of the formula now. So we're dividing through both sides so that Q can be equal to, what is 30 divided by 0.2? That is exactly 150, right? When you do your computations on your calculator, you should find 150 as an equilibrium quantity, which is exactly the same, you know, the same thing that we found in the previous conversation. Okay? We are trying to revise the topic called supply and demand. That's why I'm trying to explain quite a lot of things just on one question. Then now, if you want price, since you already have the equilibrium quantity, you can, if you want, you can still pick this one, which says price for demand is equal to 60 minus 0.1 Q. And you say 60 minus 0.1, where there is Q, you put this 150. All right. So that will be 60 minus 0.1 times 150 is 15. So that you say 60 minus 15, it gives you 45. You see that the price, the equilibrium price is 45, which is exactly the same message that we are sending again and again. Okay. So now, colleagues, this message has been received. At least that's how you find the equilibrium price. And also that is how you find the equilibrium quantity. Given different forms of the functions, either you are given the inverted functions or you're given the normalized functions. Please work with those and you should be good. Okay. Now another point comes up, that is part B of the question. This one is saying, what happens if the price is set above or below the equilibrium? We need to do the graph. All right, let's do a simple graph for this. A simple graph. You can graph these functions. So if you want to graph, for example, the demand function, we know that there is a price here, there is also quantity, right? Down. Because the demand curve function moves like this. So we want to find the number here on P and also on Q. What do we do? Get the demand function. If you want P, set Q equal to 0. The demand function is Q equal to 600 minus 10P. If we want Q, we set P equal to 0, so that Q can be equal to 600 minus 10 times 0, which gives us 600. And that simply means that the quantity, the intercept that you have for quantity is 600. That's what you have here on quantity. And then for demand, for price, the same function that we have. If you want price, you set quantity now. You set quantity equal to 0. So it will be quantity is equal to 0. Then you have 600 minus 10P. So we are making P the price the subject of the formula, so that 10P can be equal to 600. And you divide through by 10, so that the price can be equal to 60. So on top here, you'll find the 60 as the major price, as the maximum price. So you can just easily draw the line now that cuts, joins this. This is your demand function. Is that clear? That's how you draw the demand function. Just find the intercepts, the intercept on price and also the intercept on demand. I repeat, if you want the intercept on quantity, set the price equal to 0 of the demand function. It will give you the maximum quantity. And if you want the intercept on price, set quantity now equal to 0. Then you will solve for P. You have the maximum price. The equilibrium ones, you already know them, right? You already know the equilibrium quantity, right? And the equilibrium price. We said the equilibrium price is 45. That's what we calculated. And then the quantity is 150, right? It's 150. So you can just draw a simple line, this and that. Where do they meet? Where they meet, that is where the equilibrium is. But you have to get the supply function as well and graph it. It says quantity is equal to 10P, equals, this is equals 10P minus 300. So if we set Q equal to 0, to get the price. Let's get the price. So it will be 0 equals to 10p minus 300. So that we are making p the subject of the formula. You have 300 equals to 10p and divide through by 10 both sides, so that the p can be equal to what? 300 divided by 10 is 30. So you have 30 somewhere here. So the supply function is cutting here. That's the intercept. It's cutting on 30 and it will move like this vertically, because cutting on the medium. So this is the graph that I was talking about. This is how you graph the function. Please, you start with the demand function. That's the easiest way of graphing this. This is the supply, this is the demand function. Now the question was on B, what happens if the price is set above the equilibrium? Which means it is somewhere here, maybe between 45 and 60. What really happens? See, I'll call this as Q1. I'll extend the line to the supply and call this as Q2. If you have observed clearly, what you're going to see is excess supply, right? When it is set above, there is excess supply. So the quantity demanded is Q1. What is being demanded is just Q1 at this price. Say maybe this price is 50. It's above equilibrium. The demand will be little, but the supply will increase from 150 to Q2. This is a certain number. It is between 150 and 600. Let's assume maybe this is 600. All right. You can easily find the exact quantity by substituting this price, the exact price, let's say 50 here, into the supply function. You find the exact number here. So now this number, if you check, is higher than the equilibrium quantity. What that communicates to you is that you now have excess supply. What has been supplied, the quantity that has been supplied is higher than the quantity that is being demanded. And this is the message that we are sending, especially when the price is set above. Now your question is, what about if the price is below equilibrium? Let's say maybe, for example, it's down here. Let's say this is 35, it's below 45. When you draw a straight line to the supply function is still Q1 down here. But when you extend this line towards the demand, you've seen the demand line is here. This is going to be, say again, maybe Q2. If you have seen here, you find that when the price is reduced, quantity supplied now reduces to Q1. But the quantity demanded does increase because our price has been reduced. And this is to render obedience to the law of demand and the law of supply. Remember, the law of supply states that there is a positive relationship between the quantity demanded and the price. That is to say, when the price increases, then the quantity supplied increases as well, and vice versa. The law of demand, argues that there is a negative relationship between quantity demanded and, price. That is to say, when the price increases, then the quantity demanded reduces and vice versa. So that's what is actually happening in this particular diagram. So to summarize everything that we are saying, when the price is set above the equilibrium, what do you have? You have excess supply. But when it is set below the equilibrium, we have a shortage, because at this time, demand is now greater than supply. When it is set below the equilibrium, we have shortage, but above equilibrium, we have excess supply. So when you're giving an explanation in an exam, you would draw this graph a bit and then write on the graph and give your explanation of what really happens. Okay. So we have talked about market clearance, or having the, demand equal to supply. That is called market equilibrium. That's what we have talked about. So I've talked about it from starting from the functions. If you're given the functions, how do we really show this relationship? Or how do you really show market equilibrium from the functions? Mathematically, we have shown you how it is done. Then graphically, you already know, and we have shown you how to draw, how to move the information, navigate from the graph, from the math that you have the functions, and put the functions on the graph. This is what we do. Now we have graphed these functions, and we can still explain the same message again. All right.